Hi everyone, welcome to our YouTube channel AskPrep. In today's video we are going to discuss about light. Let's get started. Introduction to light. Pierre Gassendi, 1590 to 1655, an atomist, proposed a particle theory of light which was published posthumously in the 1660s. Isaac Newton studied Gassendi's work at an early age and preferred his view to Descartes' theory of the plenum. Newton's theory could be used to predict the reflection of light but could only explain refraction by incorrectly assuming that light accelerated upon entering a denser medium because the gravitational pull was greater. Light. The fact is that light exhibits behaviors that are characteristic of both waves and particles. Light is a form of electromagnetic wave that causes the sensation of vision. The wave nature of light was first illustrated through experiments on diffraction and interference. Like all electromagnetic waves, light can travel through a vacuum. The transverse nature of light can be demonstrated through polarization. Light is sometimes also known as visible light to contrast it from ultraviolet light and infrared light. Other forms of electromagnetic radiation that are not visible to humans are sometimes also known informally as light. Optics. Optics is the branch of physics which deals with the study of light. It is mainly divided into three parts. Geometrical optics or ray optics. It deals with the reflection and refraction of light. Wave or physical optics. It concerned with nature of light and deals with interference, diffraction, polarization. Quantum optics. It deals with the interaction of light with the atomic entities of matter such as photoelectric effect, atomic excitation, etc. Next is light is produced by one of two methods. Incandescence is the emission of light from hot matter, T800K. Luminescence is the emission of light when bound electrons fall to lower energy levels. Sources of light. Those bodies which emit light in all directions are called sources of light. The sources can be point one or extended one. The sources of light are of two types. 1. Luminous sources. Those objects which by itself emit light are called luminous sources. Example: sun and stars, natural luminous sources, electric lamps, candles and lanterns, artificial luminous sources. 2. Non-luminous sources, those objects which do not emit light but become visible only when light from luminous objects falls on them. They are called non-luminous sources. Example: moon, planets, natural non-luminous sources, wood, table, artificial non-luminous sources, etc. Medium of light, substance through which light propagates or tends to propagate is called a medium of light. According to the medium of light, objects are divided into three parts. 1. Transparent object. Bodies that allow light to pass through them, i.e. transmit light through them, are called transparent bodies. Example: glass, water, air, etc. 2. Translucent object. Bodies that can transmit only a part of light through them are called translucent objects. Example: frosted or ground glass, greased paper, paraffin wax, etc. 3. Opaque object. Bodies that do not allow light to pass through them at all are said to be opaque objects. Example: chair, desk, etc. Rectilinear propagation of light. Light travels in a straight line. In vacuum or air, light travels with the velocity of 3 times 10 to the power 8 meters per second. Speed of light. The speed of light depends upon the medium through which it travels. The speed of light in a vacuum is a universal constant in all reference frames. All electromagnetic waves propagate at the speed of light in a vacuum. The speed of light in a medium is always slower than the speed of light in a vacuum. The difference is usually negligible when the medium is air. The speed of anything with mass is always less than the speed of light in a vacuum. The speed of light in a vacuum is the universal speed limit. The speed of light in a vacuum is fixed at 299,792,458 meters per second by the current definition of the meter. Reflection of light. When a beam of light falls on any surface, a part of it is sent back into the same medium from which it is coming. This phenomenon is known as the reflection of light. The ray of light which falls on the mirror surface is called the incident ray. The angle of incidence is the angle made by the incident ray with the normal at the point of incidence. The ray of light which is sent back by the mirror is called the reflected ray. The angle of reflection is the angle made by the reflected ray with the normal at the point of incidence. The normal is a line at right angle to the mirror surface at the point of incidence. Laws of reflection. 1. Incident ray, normal ray and the reflected ray all lie in the same plane. 2. The angle of reflection is always equal to the angle of incidence. Del I is equal to del R. Mirror. It is a highly polished surface, which is quite smooth and capable of reflecting a good fraction of light from its surface. Object. Anything which gives out light rays, either its own or reflected, is called an object. 1. Real object. All physical objects and light sources are real which either scatter light rays or produce light rays. 2. Virtual object. When converging incident rays, incident on eye or an optical device, there is no single point from which light rays are coming. In this case we say object is virtual. Image. The reproduction of object formed by mirror or lens is called an image. Real image. An image which is formed by actual convergence of the rays of light is called real image. It can be obtained on a screen. Virtual image. An image which only appears to the eye to be formed by the rays of light is called virtual image. It cannot be obtained on a screen. Plane mirror. The images formed from a plane mirror are the reflected images in their normal proportions but reversed from left to right. These are the most widely used mirrors. Structure and working of human eye. Definition of human eye. The human eye is one of the most sensitive sense organs of sight which enables us to see the wonderful world of light and color around us. It is like a camera having a lens system and forming an inverted, real image on a light-sensitive screen inside the eye. The structure and working of the eye is as follows. See the image. Parts of eye. Cornea. It is the transparent spherical membrane covering the front of the eye. Iris. It is the colored diaphragm between the cornea and lens. Pupil. It is the small hole in the iris. Eye lens. It is a transparent lens made of jelly-like material. Ciliary muscles. These muscles hold the lens in position. Retina. It is the back surface of the eye. Blind spot. It is the point at which the optic nerve leaves the eye. An image formed at this point is not sent to the brain. Aqueous humor. It is a clear liquid region between the cornea and the lens. Vitreous humor. The space between eye lens and retina is filled with another liquid called vitreous humor. You should also know that the retina is the coating of the interior surface at the back of the eye. It consists of an array of light-sensitive receptors called rods and cones which convert the light energy into electrical signals. It plays the role of the film in a camera. Rods are sensitive to dim light and do not respond to color. They allow us to see in dim light conditions. Cones are sensitive to bright light and color, blue, red and green. When image is formed on the retina, the image is inverted, real, and diminished. The ability of the eye to form an image on the curved surface of the retina is extremely important in human vision. The blind spot, located where the optic nerve meets the eye, contains no photoreceptors. The optic nerve transmits impulses to the brain. A crossover takes place. The optic nerve of each eye sends the information to the opposite hemisphere of the brain. One eye is usually dominant, controlling perspective. The use of two eyes, binocular vision, is necessary to obtain the correct perception of depth. Power of accommodation. The images of the objects at different distances from the eye are brought to focus on the retina by changing the focal length of the eye lens, which is composed of fibrous jelly-like material, can be modified to some extent by the ciliary muscles. Near point and far point. The nearest point at which a small object can be seen distinctly by the eye is called the near point. For a normal eye, it is about 25 centimeters and is denoted by the symbol D. With advancing age, the power of accommodation of the eye decreases as the eye lens gradually loses its flexibility. For most of the old persons aged nearly 60 years, the near point is about 200 centimeters and corrective glasses are needed to see the nearby objects clearly. The farthest point up to which our eye can see objects clearly, without any strain on the eye, is called the far point. For a person with normal vision, the far point is at infinity. Persistence of vision. The image formed on the retina of the eye does not fade away instantaneously when the object is removed from the sight. The impression, or sensation, of the object remains on the retina for about 1/16th of a second, even after the object is removed from the sight. This continuance of the sensation of eye is called the persistence of vision. Color blindness. The retina of our eye has a large number of light-sensitive cells having shapes of rods and cones. The rod-shaped cells respond to the intensity of light with different degrees of brightness and darkness, whereas the cone-shaped cells respond to colors. In dim light, rods are sensitive but cones are sensitive only in bright light. The cones are sensitive to red, green, and blue colors of light to different extents. Due to genetic disorders, some persons do not possess cone-shaped cells that respond to certain specific colors only. Such persons cannot distinguish between certain colors but can see well otherwise. Such persons are said to have color blindness. Driving licenses are generally not issued to persons having color blindness. What is cataract? Sometimes due to the formation of a membrane over the crystalline lens of some people in the old age, the eye lens becomes hazy or even opaque. This is called cataract. It results in decrease or loss in vision of the eye. Cataract can be corrected by surgery leading to normal vision. Defects of vision and their correction. People with normal vision can focus clearly on very distant objects. We say their far point is at infinity. People with normal vision can also focus clearly on near objects up to a distance of 25 centimeters. We say their near point is at a distance of 25 centimeters from the eye. Short-sightedness or myopia. Nearsightedness, also known as myopia, is a condition in which the eye can focus only on nearby objects, while distant objects appear blurry. This happens because the far point of a myopic eye is not at infinity, instead, it's closer to the eye. Myopia can occur if the eyeball is elongated or if the cornea has excessive curvature, causing light entering the eye to focus in front of the retina rather than directly on it. This defect results in a blurred image of distant objects. For people with myopia, the far point might be only a few meters away instead of at infinity. This condition is corrected using a diverging, concave lens, which helps to shift the focal point back onto the retina, allowing for clearer vision of distant objects. To correct short-sighted vision, a diverging lens, concave lens, of suitable focal length is placed in front of the eye as shown in figure. The rays of light from distant object are diverged by the concave lens so that final image is formed at the retina. If the object is very far off, then focal length of the concave lens is so chosen that virtual image of the distant object is formed at the far point F of the short-sighted eye. Therefore, rays of light appear to come from the image at the far point F of the short-sighted eye and not from the more distant object. Far-sightedness or hyperopia or hypermetropia. Far-sightedness or hypermetropia is a vision condition where the eye can clearly focus on distant objects, but close objects appear blurry. This is because the near point of a hypermetropic eye is farther away than the normal 25 centimeters. Hypermetropia can occur if the eyeball is shorter than average or if the cornea has insufficient curvature, causing light entering the eye to focus behind the retina instead of on it. In a farsighted person, the near point may be several meters away rather than 25 centimeters, which is typical for a normal eye. This condition may result from a smaller than usual eyeball diameter or the inability of the eye lens to curve adequately when the ciliary muscles contract. As a result, when an object is placed at the normal near point, 25 centimeters, the image is formed behind the retina, leading to a blurred image of close objects. To correct hypermetropia, a converging, convex lens is used. The convex lens helps by shifting the focal point forward, allowing the eye to focus on nearby objects as close as 25 centimeters. This lens of appropriate focal length creates a virtual image at the actual near point of the farsighted eye, enabling clear vision of close objects. Presbyopia. This defect arises with aging. A person suffering from this defect can see neither nearby objects nor distant objects clearly distinctly. This is because the power of accommodation of the eye decreases due to the gradual weakening of the ciliary muscles and diminishing flexibility of the eye lens. This defect can be corrected by using bifocal lenses. Its lower part consists of a convex lens and is used for reading purposes, whereas the upper part consists of a concave lens and is used for seeing distant objects. Care of the eyes. If advised, we must use suitable spectacles. Too little or too much light is bad for eyes. Insufficient light causes eye strain and headaches. Too much light, like that of the sun, a powerful lamp, or a laser torch can injure the retina. We should not look directly at the sun or a powerful light. We should never rub our eyes. If particles of dust go into our eyes, we should wash our eyes with clean water. If there is no improvement, we should go to a doctor at the earliest. We should wash our eyes frequently with clean water. We should always read at the normal distance for vision. We should never read by bringing the book too close to our eyes or keeping it too far. If food is deficient in some components, eyes may also suffer. Lack of vitamin A in foodstuff is responsible for many eye troubles. Most common amongst them is night blindness. We should, therefore, include in the diet components which have vitamin A. Raw carrots, broccoli and green vegetables such as spinach and cod liver oil are rich in vitamin A. Eggs, milk, curd, cheese, butter, and fruits such as papaya and mango are also rich in vitamin A. Thanks for watching. We hope you enjoyed learning about light. Don't forget to like, share and subscribe for more exciting science videos. See you next time.